Alrighty, in this example I wanted just to show you how you would graph a non-linear function. We've been spending a little time on graphing linear functions or linear equations, and so I just wanted to provide an example of what a non-linear function would look like on the table as well as on the graph. And your homework assignment provides a couple of other examples. You're going to be given x values, you're going to plug them into the equation or the function like I'm going to show you here in a minute, and then you're going to take those coordinates and plot them on the graph to represent that function. So now they're going to look differently. This is just one example. You might not have parentheses. You likely will have some exponents thrown in the mix, and just kind of see how that plays out for you. Now, it is written in function form, but really this function of x, or f of x, sometimes you say it that way, is really the same thing as the output or the y value. But this is just another way to write it out. Now what we're going to do is plug in our x value into this portion of the function, and let's see what we come up with. So in this case we've got negative 2 minus 4, and then we'll square that. Now negative 2 minus 4 is going to give me negative 6, and then of course I'm going to square that. That's the same thing as saying negative 6 times negative 6, and that's going to give me a positive 36. Now we're going to take the 0 and plug it in where the x is. So 0 minus 4 squared. Well, 0 minus 4 is minus 4. And when we square that, that's the same thing as negative 4 times negative 4, which will give us 16. Now if you want to stop the video and finish plugging in these values and find your y values, go ahead and do so. I'm going to go ahead and keep going though. So we've got 2 minus 4 squared. That's going to be 2 minus 4 is negative 2 squared. That's negative 2 times negative 2 gives me a positive 4. Now we've got 4 minus 4 squared. That's going to be 0 squared. Well, I know that's going to be 0. Now we've got 6 minus 4 squared. That's going to give me a positive 2 squared. 2 times 2 is 4. And then let's try the 8. 8 minus 4 is square, and square that. 8 minus 4 is 4, and 4 squared is 4 times 4, which is 16. Okay, now you might, there could be any number of x values that can be plugged in, and you're going to be able to get enough information to draw your graph. These are just a sampling of numbers, values that we can use. And so let's go and use these values now and plot the points. Remember, when we're plotting points, we need an x and a y value, and so these are now our coordinates. Okay, and so you might see them as, I won't write them all down, but like this first one, you need an x and a y, and so it would be negative 2, 36, or positive 36, and that would be our first coordinate. Now on your assignment you're going to be given some graphs that are already show the x and y axes, but let me go ahead and create something on this graph paper here, so we can just work with what we have here. So my horizontal line, of course, is the x-axis. Okay, I'll write it up here, x-axis. And the vertical line that goes through it is the y-axis. Okay, so I'm going to start off, well, I don't think I have 36 lines going up and down, so I'm going to go ahead and divide these up into by 5. So we'll go 5, 10, 15, 20, 25, 30, 35, 40, and I'll just label them by tens. You get the idea. And I think I'm just going to label these by ones, because I don't need to break them up like the others. I don't have that many numbers. I don't think I need all of these. So let's see. I know I need to go as far as -2, so here'd be -1 and -2, and then I do need to go to 8, +8 for on the other side. So that's 1, 2, 3, 4, 5, 6, 7, and one more would be 8. It doesn't look like I need to do any negative y values. All of these y values are going to be positive numbers. Okay, so we're going to begin. The first one has a -x and a +36. Let me change colors here as I plot. So -2, and then I'm going to go up to +36. That's going to be about right here, a little bit above 35. Our next one is 0, 16. So here's 0, and I'm going to go up to 16, so that's 20. Here's 15. So right above the 15 would be 16. Now we've got 2 and 4. So the x is 2, and then we're going to go up 4. Now this one's 5, so it's going to be right around here. All right, the next one is 4 and 0. So the x value is 4, and the y is 0, so it's going to be right on this x-axis here, okay? Next we have an x value of 6 and a y value of 4. So here's my 6, and I'm going to go up 4. 1, 2, oops, no, I can't do that. Here's 5, so it's going to be right around here. Similar to the 2, 4, notice that the y value is the same for the 2 and the 6. Okay, now the last one that we have a value for is the 8 and 16. So here's our 8. Here's 15, 16. And notice there's a similar one. The 0 also had a 16 as a y value. So you can kind of see, I don't know if you can see these dots very well, or these points, kind of goes down, but then it swoops up. And if we had some more values, it would probably continue to swoop up. And so you could, just carefully kind of sketch, and it doesn't have to be perfect, but you can kind of do a little bit of a sketch, passing a curved line in there, and just draw an arrow on both ends, because it's going to continue both ways. Notice that this is not a straight line. So this equation, or this function, is non-linear, okay? If it were to create a straight line, you would get out your ruler and line up the points, and it indeed made a straight line, then it would be a linear function. But this is non-linear, and so we're going to go ahead and just write the function next to the graph. But this is non-linear. Okay, and actually this is an example of a quadratic function, but all you need to know for now is that it's non-linear.